Welcome everyone to this explainer. Okay, so today we are setting out to explore a topic that generates a massive amount of buzz, a fair amount of confusion, and honestly an incredible amount of excitement. We're talking about the world of quantum computing. We hear these terms like qubits, quantum supremacy, and encryption threats thrown around in the news literally all the time. But what does it all actually mean? Well, we're going to break it down. By the end of our time together, you're going to see exactly why governments and tech giants are racing to master this tech and how it's poised to fundamentally change your understanding of the universe.
Let's dive right in with a really powerful analogy. When tech creators Cleo Abram and Marques Brownlee were wrapping their heads around this, they spoke with a renowned quantum physicist who offered a perspective that absolutely reshapes how we view these machines. He said, quantum computers are not faster cars. They're boats built for entirely different terrain. It's super common to think of a quantum computer as just, a super-powered version of the laptop sitting on your desk. But actually scratch that idea completely. They aren't just bigger or faster, they operate on a totally different set of rules.
Section 1. Navigating the mathematical map. To really grasp what that quote means, imagine all of human knowledge. Our ability to solve math, physics, science problems is a giant video game map. In the past, answering questions required pencil and paper. We were effectively exploring the map by walking. It was painfully slow, and vast areas were just too far away to ever reach. Then, early computing limitations drove us to innovate. Past inventions, like those massive vacuum tubes, paved the way for early processors. They acted like horses, speeding up our journey. Today, with modern silicon processors, we've paved roads and we're driving fast cars. We're navigating the map faster than ever. But here's the catch. There are still parts of this map, vast, deep oceans, that cars simply cannot drive over, no matter how fast you push them. Section 2. Qubits, computing with waves. And this brings us to the quantum shift. To explore those mathematical oceans, we need entirely new vessels. Inside IBM's actual quantum setup, the machine is housed in a dilution refrigerator that keeps it at 15 millikelvin. Just to put that into perspective, that is literally colder than the vacuum of outer space. Why go to those extremes? Because classical computers are our cars on a roadmap. They run on bits, strict zeros and ones. They're rigid and great at addition. Quantum computers, however, are our submarines in the deep ocean. They run on qubits, operating on wave probabilities. They aren't going to replace your smartphone. They are highly specialized machines built to find hidden structures in massive amounts of data.
Now, if you're a student tuning in right now, especially if you're looking at educational pathways in physics, computer science, or a career in quantum research, you really have to rethink the basics here. A qubit is not a tiny switch. Don't think of it as a 1 or a 0. Think of it as a wave. It has a probability of being a 0, which is a lower energy wave, and a probability of being a 1, a higher energy wave. Wrapping your head around this probabilistic nature is your absolute first step into the quantum world.
To visualize how multiple qubits work together, imagine tapping two different places on the surface of a super calm pond. Ripples spread out, right? Eventually, those ripples crash into each other. Sometimes they build each other up into larger waves. That's constructive interference. Sometimes they cancel each other out. That's destructive interference. This is exactly what's happening inside that freezing cold dilution refrigerator. The probabilities of multiple qubits are interacting like ripples in a pond. So there's this huge misconception that a quantum computer just tries all the passwords at once. No way. That is completely false. Instead, as the algorithm runs, it actively alters those probabilities. The computer essentially watches how all of those waves interact, how they build up and cancel out in that pond, and then pulls out the most probable solution. Section 3. Simulating nature's secrets. So we've got these freezing cold submarines navigating the mathematical waters. But what's in the water? What are we looking for? IBM researcher Olivia Lanes hit the nail on the head when she said, nature fundamentally is quantum, and it obeys quantum physics. Our classical computers really struggle to simulate nature because at an atomic level, the universe doesn't do strict zeros and ones. It operates on the wild laws of quantum mechanics. You just can't simulate a quantum universe perfectly with a classical car. You need a quantum submarine. And this is a real game changer. It perfectly illustrates how this tech could absolutely revolutionize our future. We're talking about mapping atomic behavior to discover fundamentally new materials. We could simulate chemical reactions flawlessly to design highly efficient battery technology, which could realistically solve our energy crises. We could even create incredibly advanced targeted new medicines by seeing exactly how molecules fold inside the human body. The potential here is just massive.
Section 4, the quantum security threat.
But okay, while simulating nature is the dream, there is another capability that has governments worldwide kind of sweating right now. It all comes down to Shor's algorithm. This is a specific quantum algorithm designed to efficiently find prime factors for extremely large numbers. Why should we care? Because factoring massive numbers is the bedrock of RSA encryption. That's the protocol protecting all secure transactions, communications, and internet data today. The whole shebang.
To really grasp the threat, look at the timelines. Breaking modern RSA encryption using our fastest classical cars would literally take billions of years of brute force. But a fully functional quantum computer running Shor's algorithm, it could crack that exact same encryption in just hours or days. This is exactly why there is a fierce global race for quantum supremacy right now. Whoever perfects this machine first is going to hold an unbelievable advantage in cybersecurity.
But hey, don't panic and empty your bank accounts just yet. Take a look at this number, 433. At the time this research was compiled, IBM's record-holding quantum computer operated at 433 qubits. To actually run Shor's algorithm and break global encryption, experts estimate you'd need upwards of 1 million qubits. So we aren't quite there yet. Our submarine is built, sure, but it can't dive to the deepest trenches of the ocean quite yet. That being said, the tech industry is definitely not sitting around waiting for that 1 million qubit machine to drop. Researchers predict that in the next 5 years, maybe less, we're going to see a massive shift. Institutions are actively moving away from RSA right now, transitioning to quantum-safe algorithms. It's a proactive switch happening over the next half-decade to make sure our data stays secure long before the hardware ever scales up to become a real threat. Section 5. Exploring the bottomless ocean. Let's bring this explainer back to our core analogy to look at the incredibly optimistic future of this tech. We traded our cars for submarines, and right now, in step 1, we're just skimming the surface with early records like 433 qubits. But moving to step 2, engineers are scaling this hardware fast. And here's the kicker, there is absolutely nothing in physics preventing continuous improvement. If physics allows it, we will build it. Which brings us to step 3. As our submarine dives deeper year by year, we are guaranteed to discover unpredictable, mind-blowing applications. And that brings us to our final thought. The potential of quantum computing isn't just about making our tech faster, it's about our fundamental human desire to understand the universe we live in. The world is quantum mechanical, and for the very first time in human history, we finally have the right vessel to explore it. So I leave you with this to think about. As this technology scales and our submarine dives deeper and deeper, what incredible secrets will we discover down there in the bottomless ocean? Thank you so much for joining me for this explainer, and definitely keep your eyes on the quantum horizon.